Hi, my name is Walker Daniel, and this is my Lab 1 charge tapes. Introduction. The purpose of this lab was to show the interactions of the two charges pieces of tape. Additionally, we had to find the charge of the tape and then create a computational model that also represents this. And a little teaser based on the data, the tape is positively charged with a charge of 9.3 repeating e to the negative 8, and it lost around 5.83 repeating um, e to the 11 electrons. Here are some fundamental ideas that were pretty core for the whole lab. First, the gravitational force. The force of gravity is mass multiplied by the gravitational constant of 9.8. Additionally, Newton's third law, objects in equilibrium apply equal and opposite forces to each other. And then finally, electrical force, and that's the equation right here that we used for a lot of our calculations. And these all came together to show exactly what we were looking for at the lab. We also had to make some key assumptions in order for our data to work. Both tapes had equal charges. There's no outside forces other than the electrical force and gravity. And then the tape charge acts as a point charge. And this allowed us to do a lot of the simple math that I've been worried with a lot of nuanced data. For our experiment, first to our system was the suspended tape, and the surroundings was the earth and the lower tape. And here are the steps we did. First, we had to charge the strips of tape. As you can see in figure 2, this is how we accomplished that. Then we brought the charge strips to different objects and noted their observations. Then take two charged tape and suspend them above the others so that it makes a small dip in this figure here in B. And then finally move the lower tape up until the upper tape begins to move upwards and create like a levitation effect. And then finally note down the distance um, that the tape caused the movement. Here are the measurements we got. The mass was 0.0002 kilograms. The length was 0.2 meters. Tape surface area was 0.004 meters squared. The distance between the tape was 0.2 meters. Force of gravity was um, this huge number, and electrical force was the opposite of this, and this could be seen in Newton's third law. Observations: two charged tapes repel, charged tape and hand attracted, charged tape and discharged pen attracted. And so, based on this, we can see that the tape is positively charged because it attracted to the negatively charged pen. And here is the forces on the the upper tape. As you can see, there's the electric force upwards and gravitational force downwards, and they are equal, therefore creating a floating effect. This is my code. My variables were right here. This is where I did all the math. And then finally, there's the visuals effect right here. And this is what my code outputted. As you can see up here, that top dot represents the upper tape and the bottom dot represents the bottom tape. And then here is the data spit out with all my math. Of course, there were some possible errors. My data wasn't perfect. There were rounding errors, I'm sure. Possible outside forces. Tape could have lost charge quickly due to handling it too much, and then finally calculation errors. I'm not a computer, so I'm not great at math. Here are some future questions. What if the electrons were positively charged and protons were negatively charged? For this experiment, nothing would really change because it'd still be like charges repelling. And then finally, why is it important to handle the tape carefully? As I mentioned earlier, if we handle the tape too much, it could possibly transfer the charge and make it neutral again. And that's all. Thank you.